Hello, everyone. Today, let's talk about some of the basic AWS concepts, VPC and IAM. VPC stands for Virtual Private Cloud. It is basically to provide your own private network. You could have multiple private networks in your single AWS account, which can be basically disconnected from the public network, or it could have some of the connections established with the internet as well. So we need some other components like subnets, route tables, ACLs, and gateways to group the resources of AWS into the virtual private network, and also have the connection established between those subgroups, and also apply some of the security settings on those subgroups, and then have the gateways to connect and establish a connection between to and from the internet. So subnets are available to provide grouping of your resources into a separate block. A subnet can be a private subnet or could be a public subnet. Only a public subnet can be made accessible through the internet. Private networks, private subnets cannot be accessed through internet. However, the private subnets could be accessible from the public subnet if there are necessary routings added into the route table and there are proper restrictions set in the ACLs. Then we have route tables. So route tables are to be associated with each subnets to define the routes between these subnets in the VPC and also to the internet gateways. ACLs stands for Access Control List. They are to provide restrictions at the subnets level. So if there are private subnetworks, then the ACLs are defined with no access to the subnets from the internet. The internet important thing we need to understand from ACL perspective is that it's a stateful resource where if you are opening a connection between 2 points X and Y, you should also open a connection between Y and X. It's not the case for the security groups, but for ACLs it's stateful. There are two entries need to be added for each successful request and response from a. Then this is the diagrammatic representation of what we discussed so far. So if you look at this diagram, we have an outer boundary called VPC, Virtual Private Cloud. Which has the CIDR block defined with 192.168.0.0 of 16. And there are four subnets defined in this. So the top two are public subnets and bottom two are private subnets. So these two private subnets are cannot be accessed from the internet directly. So we have kept the database and the application server in the private subnet. So any resources which could not be accessible from the internet, they should be kept in a private subnet. And then we have made two public subnets. So one is the Bastion station, another one is the Apache web server. Both of them have to be accessed through public network. And Boston session is the concept where it is only exposed to internet, so that the other resources from other subnets could be accessible only through Boston session, so that the attack surface is minimized. If some reason, if the Boston session is compromised, it basically we are still managing to block the access to the other resources. And we have a public Apache web server defined public subnet. This allows only HTTP from the internet and SSH from the Bastion session. That is because the Apache web server should be accessible to the internet but for the users with the port number 80 in order to respond to the request. And again, the necessary routes should be added in Apache web server to access the application server. And as the route table should be added in the application server to access the database. And necessary route tables have to be added in the Boston session now to access the resources in the web server, application server, and database. And there is an internet gateway component have to be added, which allows the internet connectivity from the public network reachable through either to the Bastion station or through the Apache web server. Without this internet gateway, you won't be able to access to any of these resources, especially the Bastion station or the Apache web server from the internet. And if there is a resource in the private subnetwork which need access to the internet for any of the reason, then there should be additional component required called NAT gateway, which should be placed in the VPC so that this private subnet resources can reach to the internet through the NAT gateway. For example, the EC2 instance here requires an update from the internet. It will not be able to access without the NAT gateway. We are moving on to the next topic called identity access management. So identity access management is a shared responsibility environment in AWS where both the AWS and the consumer of those resources have the responsibility on the respective sections. AWS ensures that it provides necessary restrictions on the data centers and power outages and disaster management and software upgrades. So those are all responsibilities comes under AWS. As far as the consumer perspective, consumer is the one who is responsible for restricting the unwanted access from outside world on the resources. For example, if a user wants to have a EC2 instance provision and wanted to restrict the unwanted access, then necessary restrictions have to be added by the user by using the features given by the AWS. So it's a shared responsibility environment. Now also it is important to keep the softwares up to date in order to have the security vulnerabilities controlled. Then, so this IAM is for both authentication and authorization, and there are security groups can be defined, which can filter the request based on the protocol, port, and source and destination. These security groups are stateless against the ACLs, which are stateful, where in case of security groups, if you define a rule between a point X and Y, between resources X and Y, so you need to define the rule for Y to X as well. For example, if you're opening a SSH access from source internet to a resource EC2 instance, you do not need to add another rule between this resource to the internet in case of security groups. But in case of ACL, you will define two rules, one for bit to from internet to the EC2 instance, and the another rule for EC2 response EC2 instance to the internet. That's a major difference between security groups and ACL. This is the diagram which represents very well about the identity access management in AWS. So basically, it restricts the users and the resources accessing the AWS API. So we have a user who can log into console, or you can use an CLI to access the AWS API, and a group of users are group under a group, and the users and groups can be restricted attaching a policy against each of them. So a policy can be attached to a user or can to the group. And a policy is nothing but it's a set of permissions to define the accessibility of the AWS API. On the right hand side, where the access also can come from another AWS resource, a EC2 instance can get a access from the another EC2 instance. So that's where the role has to be defined for a resource-based access, and policy should be attached to a role, which defines the permissions for that particular role, allowed for that role, and all the resources, required resources, can be attached to that role. So, for example, if an EC2 instance need an access for another resource, then a role has to be defined. So the role is to basically to say the authenticate the AWS resources, and that role has to be attached to that particular EC2 instance. And there should be a policy which defines what kind of actions allowed on that particular by the EC2 instance. Then the particular policy has to be attached to that role. So this way, AWS manages the access management both for the users and for the resources. That's all I have for today. Thanks everyone for watching.